We have been talking for more than a month now about this series of low pressure systems, one after another, bringing us rain and storms. But what exactly does that mean? Meteorologist David Yeomans explains in this First Warning Weather University report. It's all just wind.
Wind is defined as the movement of air. In the natural world, it's caused by differences in pressure. Atmospheric pressure is the weight of the atmosphere above us constantly squishing down on us. On a typical day, the weight of the atmosphere exerts a pressure down on the Earth of about 14.7 pounds per square inch. So the grass in our front yard, the water in the lakes, even our bodies are constantly under that pressure, but we don't really notice it because we are accustomed to it. Now, when a storm blows in, rising air feeding that storm actually lifts some of the weight of the atmosphere off of you, so the pressure drops. On a bright sunny day, there's actually air sinking down upon us, so the atmosphere seems to weigh a little bit more and the pressure rises. So let's take a look at a small scale example of all this. Let's say we have a storm in downtown Austin, but the sun is shining out over Lake Travis. This means there's a little low pressure system over the city and there's a high pressure system over the lake. Air always blows from high to low pressure. It's the same exact principle that allows airplane wings to generate lift. In our example here, the wind would be blowing eastward, and the bigger the difference in pressure, the stronger the wind would be. Here's the complicating factor. On a rotating planet, the Coriolis force comes into play, which adds a spin into the mix. As the air is blowing from high to low back over Austin, it's being deflected rightward since we're in the northern hemisphere. The air ends up spiraling inward toward the center of the low pressure, which is how we end up with these counterclockwise rotating storms. The Earth is always trying to reach an equilibrium, evening out the pressure everywhere, but it's never quite able to, so the winds will always blow.